The important part of this was the pressure sensor and the flow gauge were after the flow meter, which is a turbine type. And there's a big pressure drop across that flow meter. So that was appropriate. We wanted to check on that. We looked at calculating pressure and flow from the pressure transducer. For the test, I am not going to ask you to run through the Wheatstone bridge and the excitation voltage to go from millivolts to pressure. Okay, that won't be on the test. But what will be on the test is if I have or might be for the test, available for the test, would be if I have a calibration for a flow sensor in terms of pulses per liter, and I have an output from a flow sensor in terms of hertz, pulses per second. What's the flow rate? Well, the example for that would be if we had a flow meter that had an output flow meter now that's measuring the flow of 244 pulses per second. Okay, and that's what we had for our lab. And the calibration for that was in terms of 3,200, I believe it's 3,200 pulses per liter. Okay, and I can just invert that and put that on there. That was the calibration? Yes. And now I don't want this is going to give me in liters per second, so I'm going to multiply that times 60, and that's going to be 60 seconds per minute. Okay. So what happens is the pulses cancel, the seconds cancel, and what I have left is liters per minute. And most people did that correctly, and they got about 4.58 liters per minute. Okay. Well, I'm going to convert everything to gallons per minute. I know we live in a metric world, but well, we don't actually live in a metric world. But I'm going to convert things to gallons per minute so that we have a feel for that. Now, what's the conversion between liters and gallons?
0.2642 gallons per 1 liter.
Good. And I actually have the inverse of that because I know that there's 3.785 liters per gallon. Okay. Should be the same. Right. And the reason I know that is because I look at my milk jug every morning and I just confirm that. Now, some guy actually came up to class and he said, and he had a Coke class and he was looking for the conversion of liters, to, and I'm just kind of look at your Coke thing, kind of help you out in terms of your conversion. But they didn't know. I expect you to know something like that. Some certain things you got to know how many liters there are in a gallon. Now, so if I figure that out, I'm going to get so many gallons per minute, and that turned out to be, and I'm going to just jot this down, 0.302 gallons, well, not 0.302, but I'm going to divide this by 4 because this is for all 4 nozzles. So if we divide all this by 4, because we have 4 nozzles, and I'm trying to get the flow rate out of each nozzle. That's what I'm looking for right now. Average flow rate out of each nozzle. I've got to get that out of here. Then I'm going to get a value for my flow rate of 0.302 gallons per minute out of my nozzle. 0.3, that's kind of fat. So that's what I got for my flow rate for one of my nozzles. And that's one way to get flow rate. Now, another way to get flow rate is if I take a look at what I actually captured. And what I actually captured were this value of 650 milliliters, 640 milliliters, 670, whatever. And the average of that, coming out of one nozzle, was 650 milliliters or 0.65 liters. per 30 seconds. Because we captured it for 30 seconds. Okay. Now, if I take that and I convert that into double it, and because there are what? We have 60 seconds per minute, and then multiply that by the fact that we have 1 gallon, there's 3.785. And everybody did this in just a different format. 0.65 liters, L, 30 seconds. Then you get the value for each of the nozzles coming out as, and I'm going to put it right over here, 0.343 gallons per minute. And I got the numbers running out, but a lot of people truncated that. 0.34 would be fine, gallons per minute. So that's one way to figure out the average or the flow rate out of each nozzle. Now the other three have to do with the pressures. And we had 3 pressures. We had the 28 psi with the gauge. We had the 22 psi with the gauge. And when we had a 28.844 millivolts coming out of the pressure transducer. And we can go walk over and see if I can actually read any of that stuff. It's over there. Oh my gosh, it's small. You get it. Okay. Now what I want to try to do now is figure out what the flow rate is out for each of my nozzles. I'm going to go back and read through the assignment and we'll see how all this fits together. So, what do? Well, I know my nozzle is a what? TK2. And thus the TK2s are designed to output 0.2 gallon per minute. Now I'm really getting small, Hannah. At 10 psi. Okay. Now I can use that as my conversion, or I could use anything on that list if I want to. But what's on that list that's after this is actually calculated. For my opinion, it's not measured. And then it's rounded off. So if you're trying to look at a nozzle and it's a TK2, that means that it's set up to output a certain flow rate from the gallon per minute at a certain pressure. TK3 would be 0.3 gallons per minute, 10 psi. So I would use this, if I was going to use one, I'd use the standard one, not any one on that list. Does that make sense? Because you can pick a whole bunch of flow rate and gallon per minute combinations, but only one of them is actually determined, measured. The other ones are calculated. Okay. So I'm going to use that because that's the basic. So I'm going to try to figure out what, at 28 psi, what should be the flow based on nozzle specifications out of that. And I used the old oath. I got the square root of 28 over 10 is equal to Q over 0.2. 0.2 gallon per minute. You can see that. Hopefully I was going to move over to the middle at some point, but started way too far. And when I do that, I get a value of, and I'm going to put it way over here, 0.335 gallons per minute. Something like that. Now, if I use 22 psi over here, I use the same equation, but I'm putting 22 over 10 is equal to Q over 0.2, and now I get a value for my Q of lower, should be lower, 0.283. And now if I use my pressure transducer output is 28.844, trust me, Hannah, that's what it says over there. And that relates to, and I have this conversion at 1 millivolts, 1 psi, that's 28